All right, if you're at home, what you're going to need for today's lesson is you're going to need to have your bell work paper, your notebook, and your homework 1.2. So pause the video, take a minute, make sure you have everything you need. Okay, here's your bell work. Draw a plane and label it W. I'm going to get you started. Take the whole area on your Tuesday paper, draw a nice big rectangle, and label it W. Now pause the video, please, and complete exercises 2 through 6. When you're done, you should have ended up with something that looks like this. So check your work, go back and fix anything that you did incorrectly, and try and figure out what you did wrong so that when you take the test next week, which there will be on your test a whole section of examples just like this where you are going to have to interpret what the words say and put it into a picture form. Okay, skip those. Okay, you're on your table of contents. This is lesson 1.2, segment addition and midpoint. So pause the video, please complete your table of contents. On your next page in your notebook, this is lesson 1.2, your objective is SWABAT, which means student will be able to apply properties of segment addition and midpoint. So pause, make a note of it in your notebook before you move on. Segment addition postulate is one of two things that we're going to learn today. So segment addition postulate, it says that if point B is a collinear point between A and C, again, B collinear means on the same line. If point B is a collinear point between A and C, take a look at the diagram real quick. B is collinear with A and C, and it is between. The segment addition postulate says that the distance from here to here plus the distance from here to here has to be equal to the overall distance. Okay, so this plus this has to equal the whole thing. And that's just common sense. If you take two little things and you add them together, you're going to end up with one big thing. Okay, so take a moment. Make sure you write the segment addition postulate in your notes. This part is important. Okay, example 1. You do not need to write this in your notes. We're just going to go over this really quickly. Okay, if line segment AB, notice how I'm reading it, line segment AB is 3, so that's saying that from here to here is 3. And line segment BC is 5, so from here to here is 5. Find AC. Well, common sense tells me that if I add 3 and 5, I'm going to get the whole line segment, which would give me 8. Example 2, find EF. So similar, not quite the same though. They're giving me the whole distance this time. I've got the whole distance of 15. They're giving me one of the smaller segments, DE, as 8. So I need to figure out what EF is. So you could set it up as an equation. You could probably do the mental math in your head. You could do it like 8 plus some number, x, equals 15. And then if you subtract 8 from both sides, you end up with 7. So 8 plus 7 is indeed 15. Okay, this example you are going to want to write in your notebook. So pause the video for a minute until you get the problem down on paper. Okay, so we're given that AC is 39. So this whole thing is 39. Then they gave me two individual pieces of this line segment AB is 2x minus 8, and line segment BC is x plus 17. Well, my segment addition postulate says that the two little pieces added together have to equal the big piece. So here we go. 2x minus 8 equals, I'm sorry, back the truck up. 2x minus 8 plus x plus 17 equals 39. All right, now here's where the algebra comes in. I told you the other day that if you didn't know how to solve equations or you weren't good at it, you're going to suffer. So pay attention if you're not sure how to do it. So I'm looking at my left-hand side of my equation. I see I have a couple of things with some x's in it, so I can put those together, which will give me 3x, 2x plus 1x. I can put a 1 there if I want. And then I have some numbers, also called constants, that I can put together. So I have negative 8 plus 17, or you could go backwards and say positive 17 minus 8, which gives me positive 9 equals 39. Okay, so I'm going to start doing some mental math here because I don't want to have to write out all my steps. I'm going to subtract 9 from both sides. And when I do that, this is going to go away if I subtract 9. If I subtract 9 from my other side, that is going to leave me with 30. So I'm left with 3x equals 30. Okay? All right, now I just have to get x by itself. I need to divide by 3. So when I divide by 3, x is going to be equal to 10. All right, so x is equal to 10. That means up here on my line segment AB, I'm going to plug in 10. So that's going to give me 20 minus 8, which is 12. And here, I'm going to plug in 10 for x. So that's 17 plus 10, or 10 plus 17, which is 27. And when I add them together, I should get 39. And I do. That's what my problem told me I needed to get. Okay? All right, pause the video for a moment and try this one on your own. Okay, take a moment to check your work and make sure that you've solved everything correctly. If not, go back and try and figure out what you did wrong. Okay, this is how you are going to see the problem presented in your homework. So make sure that you understand how to interpret the problem. A, B, and C are collinear. There's that word again. That means they're all on the same line. And it's very specific here. It says point B is between A and C. So B is someplace in the middle of A and C. So I have point A and point C. I'm going to go ahead and draw my line segment, kind of, sort of. Point B is somewhere in the middle. Doesn't say exactly where. Okay, then it goes on to tell me, I'm going to read my language again, line segment AC. So AC, that's the big one, is equal to 3x plus 3. Line segment AB is negative 1 plus 2x. And line segment BC is equal to 11. So similar concept to what we just did, except it was presented in a different way. But you're going to basically set it up the same as before. All right, so negative 1 plus 2x plus 11 has to equal 3x plus 3. And then I think you could do the math from there. All right, going to skip these. Okay, here we go. Next concept is midpoint. Okay, pause the video, take some notes. So basically what a midpoint is the point in the middle of a line, exactly like it says, midpoint, right in the middle. So if this whole segment is 10, then each of these has to be 5. I should say 10 feet. Okay, if that's 10 feet, then those each have to be 5 feet. 10 cut in half. So midpoint is exactly halfway between, and also that means the two line segments created by a midpoint are equal. All right, we have a little bit of a new symbol here. It says given line segment AB is congruent to, this is a new symbol, this is a geometry symbol. It basically means equal. It's a geometry symbol that means equal. So that reads line segment AB is congruent, let's write that down, that word, congruent, which also means equal, Okay, so line segment AB is congruent to line segment BC. Well, if line segment AB and BC are congruent to each other, that means they have to be equal to each other. So my equation is going to look a little bit different for this one. The ones we did prior to this, the examples we did prior to this, that didn't say anything about them being equal, or it didn't say anything about having a midpoint. So we were solving stuff like this, where I had different sized line segments, okay? Because they're now congruent, the line segments are the same size or equal in length, okay? So my equation for this, because they are congruent, is going to be 2x minus 8 is equal to x plus 17. Doing some mental math, if I subtract x from both sides, this is going to go away, and this is going to become 1x, or just x. If I add 8 to both sides, this will go away, and that will become 25. So x is equal to 25. Okay, same thing. I'm going to plug it in, plug 25 in for x. So 25 plus 17 gives me 42. And 2 times 25 minus 8 is also 42, which they should be equal. They're supposed to be equal, so keep that in mind. If they come out not being equal, you did something wrong. All right, and then AC, the whole segment would be 84. 42 plus 42. Okay, same type of problem, but a little bit of a different twist. Again, it says that line segment AB is congruent to line segment BC, which means that these two are equal. And here's a new geometry notation for you. If two things are congruent, we like to mark them as such. Okay, the little tick mark means that those two line segments are equal to each other. Well, if line segment AB is x plus 6, I'm pretty sure that you could guess that line segment BC also has to be x plus 6 because they're congruent, which means that x plus 6 plus x plus 6 has to equal 3x minus 31. So go ahead and pause the video right now and do the math, and then come back when you're finished. All right, take a moment and check your work. If you did anything wrong, make sure you go back and correct it and try and comprehend what happened wrong. What did you do wrong? All right, suppose that A, B, and C are collinear and AB is congruent to BC, so similar problem to the one that we just did. Go ahead and pause the video and work this one out in your notes. Okay, so this one's a little bit different setup, but not really. I'm sure you could figure it out, that if y is the midpoint of xz, then you would have to set these equal to each other to solve for x. And then once you find x, you could plug that in and find out the total distance. So take a moment to finish up that problem. And finally, similar problem, find the value of x. So it's not asking you to plug it back in, it's just saying to solve for x. And we're going to go ahead and stop there, and this is where we will pick up tomorrow.